Hey guys, so for the first lesson, we're just going to do a little review of simplifying and verifying trig identities. Okay, so I'm going to share my iPad screen with you. You should be able to see me in the top of the screen there, and now you should see my iPad. All right. Okay, so first I want you guys to just remember your trig identities that we went over. These are ones that you will have to memorize. So there are reciprocal identities. There's those 6. Again, you're not using tangent and cotangent reciprocal IDs very often. Okay, then there's your quotient identities. Those are what you're going to use for tangent and cotangent most of the time. Okay, and then here's your Pythagorean identities. So you guys should find those in your notes. You should already have those. And just remember that we can rewrite all of our Pythagorean identities at least 2 different ways than they're written already. Okay, and then when we look at verifying, remember that your goal is to transform one side of the equation into the other. You use your basic trig identities to do this. You can transform either side, but not both, which again, not always true, but I would say for the most part, general rule. And then you cannot move terms across the equal sign. Okay, and then our tips that we have are to transform the more complicated side into the simpler one, express trig functions as some form of sine and cosine, factor, you can do difference perfect squares, GCF, or at the bottom here, you can factor trinomials. So those are just a couple of ways that you can factor. And then the last thing is if you need to add something in, you can always do that by multiplying by some form of 1. All right, so let's get into, I'm just gonna do a couple of examples and then I'm gonna tell you guys what your homework is. Okay, so here are your verifying trig IDs examples. Okay, so the first one's pretty easy, or simple, not easy. And I'm gonna choose the right side. It's easier to get 2 terms down to 1. So on the right side, I'm gonna use my first tip of changing everything that's not sine and cosine into sine and cosine. Okay, so this is sine theta times, and then cotangent is cosine theta over sine theta. All right, so once I have that, I'm actually able to multiply those, and when I multiply them, my sine thetas go away. So I get cosine theta on the right, that matches my cosine theta on the left, and I have completed that example. Okay, if I'm going too fast, you guys can always pause the video so that you can get it down or rewatch. So just take advantage of that. Okay, so for this one, I'm gonna go with the left side. That seems to be the way more complicated side. And what I'm gonna do is I'm going to change tangent into sine over cosine. Whoops. All right, so I did that. It didn't really help me that much, but what it did do is it created this cosine x on the bottom of the numerator. So I'm gonna multiply the top and bottom by the LCD, which is my cosine x. I'm gonna multiply that by cosine x, and I'm gonna multiply the bottom by cosine x. Okay, so this is cosine x plus sine x cosine x over cosine x over sine x cosine x plus cosine squared x. Okay, so those cosines go away, and I'm left with cosine x plus sine x over sine x cosine x plus cosine squared x. All right, so now I can okay, so now on the bottom, I can actually pull out the cosine as a GCF. So I can make my top is cosine x plus sine x. And now my bottom is going to be cosine x times sine x plus cosine x. Okay, if you notice that this and this, they both have the same signs, so I can actually cross them out. And I'm left with 1 over cosine, which is just secant. Okay, so secant x equals secant x, and we have verified. Okay, we've got this example here, and for this example, the left side is definitely what I'm going to pick, and I'm going to start by foiling. So I'm going to go sine times tangent. So first, outer, so plus sine secant, okay, inner minus tangent, and last minus secant. Okay, then I'm going to change everything that is not sine and cosine into sine and cosine. So this is going to be sine theta times sine over cosine plus sine theta times 1 over cosine minus sine over cosine minus 1 over cosine. Okay, and I've got, again, this is 1, 2, 3, 4 terms. So here the first term simplifies to sine squared over cosine. The second term is sine over cosine. The third term is sine over cosine. And the last term is just going to say 1 over cosine. Okay, my middle two terms actually cancel each other out. So I'm left with sine squared theta over cosine theta minus 1 over cosine theta. My denominators are the same, so I can just take my numerators, combine them. Okay, and then the top is actually a Pythagorean identity. It's your sine squared plus cosine squared equals 1. I just rearranged it. So I can replace the top with cosine squared theta over cosine. And actually, hang on a second. It is a little bit opposite. So my sine squared plus cosine squared equals 1. Cosine squared theta equals 1 minus sine. So this is slightly different than that. So what would change that is if I multiplied everything by -1, and now those two are the same as each other, but it equals negative cosine squared instead of positive cosine squared. So this is negative cosine squared theta over cosine theta, which can cancel out into being just negative cosine theta, which is the original problem. Okay, so we equaled out. All right, and this is our last one. And I'm gonna pick the left side. Okay, so I'm gonna pick the left side, and this is a binomial squared. So I'm gonna write it twice. And I'm gonna FOIL it. Okay, so we've got cosecant squared minus cotangent cosecant minus cotangent cosecant plus cotangent squared theta. All right, my middle two terms do not cancel out here. Since they're the same, I'm gonna go ahead and combine them. Minus 2 cotangent cosecant plus cotangent squared theta. Okay, and I'm going to change everything that's not sine and cosine into sine and cosine. So this is 1 over sine squared minus 2 times cosine over sine times 1 over sine. Okay, plus cosine squared theta over sine squared theta. Okay, so lucky for us, all the denominators are ending up the same, so we can easily add our fractions. But I'm just going to clean up the way this looks. Okay, and we end up with 1 minus 2 cosine theta plus cosine squared theta divided by 1 minus cosine squared theta. I actually just did that because I know my final answer needs to have that in it. So I knew that my denominator could not be sine squared. So I just used my Pythagorean identity. And I used that to come up with my 1 minus cosine squared. So that's where I'm getting that from. Okay, and again, the reason I did that is because I knew that at the end, I needed to have that 1 plus cosine theta in there, and I wasn't gonna get that with just a sine squared. So I went ahead and changed it before I even started that process. Okay, so what I'm gonna end up doing is I'm gonna factor the top as a trinomial, and I'm gonna factor the bottom as a difference of perfect squares. Okay, so the top as a trinomial, we've got 2 parentheses. My first terms will multiply by 1. And then I'm looking for 2 things that multiply to be cosine squared, and that's going to be cosine theta. And I need them to add to be negative 2 cosine. So these are both going to be minus. Okay, if you took that and just made it 1 minus 2x plus x squared, then you would come up with 1 minus x times 1 minus x. And that's basically what I used to do it, except I had cosines instead of x's. Okay, then at the bottom, I know that's a difference of perfect squares, so it's going to be 1 plus cosine times 1 minus cosine. Okay, and cool thing is that my 1 minus cosines can cancel on the top and bottom, and I'm left with one of my 1 minus cosines over 1 plus cosine. Okay, and that is my answer, and that is the original problem. So we verified. Okay, I hope that helped you guys become reacquainted with the sine and cosine identities and simplifying and verifying. Your homework is actually going to be to complete that delta math activity on simplifying and verifying trig identities, and it is going to be reopened for you. So if you did not get to it, that's fine. I want you to do that though today. Okay, and don't forget my office hours are Tuesday and Thursday. Third period, you have from 11 to 12. Any Anytime you can log on, ask me a question. And on fourth period, you guys are 1 to 2, Thursday and Tuesday. Log on anytime, ask me a question. Just remember that you are required to at least pop in once a week, just so I can see you and I can account for you guys. All right, stay safe, and I'll see you next time.